You guys ready to go? Yeah. All right, cool. All right, so we're going to spend the day on 1.4 talking about quadratics. So the first idea is understanding, first of all, what a quadratic is. The quadratic in general form, so GF, general form. So I'm sure you've seen these before. It looks like this: ax squared plus bx plus c equals 0. The a, the b, and the c, these are all your constants, right? The x, of course, is your variable. But what makes this specifically a quadratic? There's something about it that makes it quadratic. Yeah, Nagana, what do you got?
Okay, it's because it has the x squared.
That's exactly right. It's this part right here, right? Because the x squared has a degree. We call that a degree of 2, right? As a squared part. So that's what makes it a quadratic. The only other thing you have to worry about is you have to make sure that the value of a is not equal to 0. Why is it important that the value of a, in this particular case, is not equal to 0? Yeah, Nelson, what do you got, dude?
So basically just make the entire, or you'll make it, just get rid of the concept of quadratic.
Yeah, exactly. It'll turn into a linear function because you'll get rid of the square. It knocks it down a notch. Okay, cool. First box, done. Easy. Second idea, dude. There are three ways to solve for quadratics. All right? 1, 2, and 3. And I'm put them in this order for a certain reason. All right? Now, does anybody have any way they can remember stuff? Yeah, Jack.
There's completing the square.
Yeah, that one's number 2. Complete the square. And we're going to review that one today. Sometimes I just call that CTS, right? Complete the square. Yes, Paige. Yeah. Quadratic formula. You got it. And we're going to talk about that one today, too. Yeah, Daniel. Factoring, you got it. And you know what? Somebody else, we always say you can also graph. But if you have some funky intercepts, it might be kind of hard to see. So these are the three main ways, and we also talk about graphing, all right? I would like you to approach this in this way. If it just says solve the quadratic and they don't give you a specific direction set, try and factor first. If you can't, move on to complete the square if your leading coefficients are 1. If that don't work, then just go straight to the quadratic formula. Quadratic formula works every single time. So, no, it works every single time. Okay? Let's first talk about the idea of solving a quadratic by factoring. All right, so let me give you 2x squared plus 9x plus 7 is 3. First of all, how do I know this is a quadratic? There's x squared. Very good. What should I do first? Yeah, Paige. Yeah. 2x squared plus 9x. Let's see here. 7 take away 3 is 4, right? On a good day. So that gives me nothing. There we go. So now I know a, b, and c, right? What's the value of a? 2. Just shout it out. How about b? 9. And how about c? 4. Good. All right. Awesome. We're going to solve this by factoring. So it turns out this trinomial here is allowed to factor into the product of two binomials. Anybody think they got it? Yeah, Tommy. 2x plus 1 times x plus 4. Now, how did you do that is the question. Tough, and I totally agree. All right. Now that we've reviewed how to factor this, okay, there is something out there in the world. There is a property that says if you have two numbers that are multiplied together and they equal 0, then you're allowed to move on. What's that called? It's called something you may know. The zero product property. Yeah, because if two numbers multiply, 2 or more numbers, you could have 50 numbers, right? But if they multiply together to get 0, then one of those numbers is guaranteed to be a 0, all right? So I want you to consider looking at 2x plus 1, that highlighted piece in blue, as a number. And look at x plus 4 as a number. So you have two numbers there. Yeah, exactly. So what you can do is you can set these up and say, all right, well, 2x plus 1 is 0, or it must be the case that x plus 4 is 0. So I've got two different answers here, right? X can either be negative 1/2 when I solve this for x using algebra, or x can be negative 4 and these are my two solutions. So I have a solution set of -1/2 comma -4, and sometimes. So try to factor or solve this quadratic by factoring 6x squared plus 3x equals. Okay, there we go. Awesome. So when we solve by factoring, factoring doesn't always mean, you know, factoring a trinomial. Sometimes you just factor out the greatest common factor, you know, and that gives you 2x plus 1. See that? So the greatest common factor of 6x squared and 3x is 3x. That's the greatest common factor. So this still equals 0, so I can apply the zero product property. So either 3x is 0 or 2x plus 1 is 0. So solving each of these individually, either x has to be 0 or x has to be negative. All right, so when we talk about completing the square, when do we use it?
After factoring.
Used when what?
The thing equals 1. Wait, it's the x squared has a coefficient of 1.
Very good. But we use it when we can't factor. And what's the goal? The goal is to create, what's known as a perfect square trinomial using b over 2. So let's come back down over here. So let's give an example here. All right, we're going to do an example, and we're going to solve by CTS. Complete the square. So if I give you x squared plus 6x plus 1 equals 0. All right, let's go through our checklist here. This is a quadratic. How come? Because x squared, good. Can we factor this thing? No, why not?
1 and 1.
Yeah. There's no product of 1 that's going to add to 6. Just not going to happen. So factoring is out. Next thing we're going to do is we're going to complete the square. You want to make sure that whatever number is in front of your x squared is a 1. This is called your leading coefficient. Your leading coefficient must be a 1. Otherwise, if it's not, you got to factor it out and make it a 1, okay? In this case, ours happens to be a 1, so I'm going to do 2 steps in 1 here. I'm going to say this. I'm going to say x squared plus 6x plus, I want you to draw a big giant box here, equals -1 plus a big giant box. All right? And I want you to tell me, what did I do? There's 2 things that I did there. What did I do? Yeah.
You subtract. We basically put the 1 on the other side of the equation.
Yep.
And then left a blank where it was.
Yes. So I created a spot. Now, this box here, this is what I call the magic number. Okay? You'll hear me refer to this a lot when I talk about completing the square. The magic number. Now, what the heck? Why would I call it a magic number? Right? What's the point of it? Yeah. What do you think?
Well, don't you divide the 6x by 2
Yep.
and square?
Yeah, now that magic number, right, comes from right up here. This b over 2 quantity squared. So what we're going to do is we're going to look at this. We're going to take a look at 6, okay? All right, we're going to say 6 divided by 2. We're going to take that value and we're going to square it. How much is 6 divided by 2? 3. 3 squared is what? 9. 9 is what I call the magic number. So 9 goes in both places because whatever you add to one side of the equation, of course you have to add to the other side of the equation. You guys with me on that part? All right, now why do I call 9 a magic number? Well, remember the goal was to create a perfect square trinomial. What I mean by that is 9 is the only number out there related to 6 in a way that this will factor to x plus 3 quantity squared. Always, always, always. Now, you may ask yourself, where does the 3 come from? The 3 comes from half of b, right there. See? That's where it comes from. Now, if you don't believe me, check this out. X plus 3 times x plus 3. This is a perfect square trinomial. The reason is, hold on one second, Paige. The reason is because when I use FOIL, I get x squared plus 3x plus 3x plus 9, and there's your 6x right in the middle. We add it together. We get how much? Yeah. So on the other side, oh, I'll use red. Keep it going here. On the other side, -1 plus 9 is 8. Okay, now we're home free. The reason we're home free is because we just solved this using square roots. So x plus 3 equals positive or negative 2 rad 2. I'm so glad that you noticed that it was a 2 rad 2. All right, when we break down the square root of 8. So I would subtract 3, so x is equal to positive or negative 2 rad 2 minus 3. And notice that there are two solutions there, right? There are two solutions there. There's the positive one and the negative one. But you leave your answer in what's known as exact factor, right? We're not going to be able to factor it. So factoring is out. What do we have to be aware of? The leading coefficient is not a 1. The leading coefficient is a 2. So how do we make? What do we do? Yeah, Daniel. Divide everything by 2. Easy enough. So x squared plus 4x plus magic number equals -3/2 plus magic number. You're allowed to do that in one fell swoop, right? Easy enough. All right. Now, what goes in the box?
4.
Yeah, we're going to look here. We're going to take 4. We're going to divide it by 2. And then we're going to square it. And, of course, we get back 4. So nothing very special there. But we get 4 there and we get 4 over here. You guys with me so far?
Yeah.
All right, cool. So 4 is that magic number. That means this entire quadratic will factor to a binomial squared. And what does that binomial look like?
X plus 2 squared.
Yeah, you can just say it. X plus 2 quantity squared. X plus 2 quantity squared. On the right-hand side, what do I have?
-3/2 plus 4, which is -2, -5, 2.5.
So 5/2, right? Let's do 5/2. All right, cool. So we're going to square root both sides. So x plus 2 is now equal to plus or minus, check this out, you guys. I have the square root of 5 divided by the square root of 2. What's wrong with this? Yeah, so I need to rationalize the denominator by rooting root 2 over root 2. After all, that is just a fancy 1, right? So I'm allowed to do that. So I get x plus 2 is equal to plus or minus, let's see here, root 5 times root 2? Root 10 all over the number 2. Very good. There's my answer. X equals plus or minus root 10 over 2. Take away 2. And we're going to leave our answer in exact form. Just 3x squared minus 4x minus 5. So the directions will be solved by complete the square. I want you to try it. Work with your partner sitting right next to you. And your answer is going to be funky. Okay? That's okay. All right, so my answer was x equals plus or minus square root of 19 plus 2 over 3. All right, we've got about 4 minutes left, and I want to just talk about the quadratic formula. And I know you've all heard it before. I know you've seen it before. I'm sure you've all looked up the song on YouTube. And I'm sure that you guys sing that song every single day. All right, so the quadratic formula, x equals -b plus or minus the square root. B squared minus 4ac all over 2a. All right, so there it is right there. You've seen it before, right? What do I call just this stuff underneath the radical? What do I call it? Yes, sir. The discriminant. Very good. This piece right here is called the discriminant. Now, the discriminant can be one of 3 types of numbers. Okay? Yes, Jenny, what could it be?
Negative, 0, or positive.
It could be negative, it could be 0, or it could be positive. Okay? If the discriminant is negative, what does that tell you?
It's a complex. It's like a complex.
Yeah, there are no real solutions, right? There is an imaginary one, right? What if it's 0? What does it tell you? There is only one real solution.
Oh, because if you apply the real life, there's no negative. Like,
You got it.
okay. And
By real, I meant real numbers. Real numbers solution. And then if it's positive, what does that mean? There are two real numbered solutions. So this is kind of a fun little diagram to help you see what the discriminant is, right? It can either be three things. It can either be positive, 0, or negative, and it tells you what each of those things are. All right? Let me give you one example, and then we are done for the weekend, okay? Connor, can you just close that door really quickly, and we'll finish up as fast as we can? All right. I want to just present to you the way that I teach solving quadratics because I think you might find it a little easier. All right? And then we're done after this, okay? The first thing I want you to do, step one, is I want you to identify the values of A, the values of B, and the values of C. So in this particular case, what's the value of A? A is 1. It's the number in front of the x squared. Very good. So A is going to be 1. What's the value of B? Yes, it's right there. I'm highlighting it. Okay. And what's the value of C? Very good. It's negative 9. I'm glad that you noticed that it was negative 9 because I'm going to move it to the other side. Negative 9. So that's what I want you to do for step one. Just figure out what A, B, and C are. Easy enough, right? Okay. Step two, what I want you to do is just figure out the discriminant. B squared minus 4AC. Just do the discriminant in step two. So that means I'm going to do 3 squared minus 4 times 1 times negative 9. So that's 9 plus 36, which is 45. Which means how many solutions am I looking for? 2 real solutions. Okay? Then, in step 3, here's the cool part. When you write down the quadratic formula, x equals negative 3 plus or minus the square root, you can just write down this number in step 2. 45. All over 2 times A, which is just 2. Check it out. If you do that, you're not going to get the algebra messed up in step 2. So step 1, just figure out A, B, and C. Step 2, give me the discriminant. Step 3, plug it in. That's the cool part, is that when you do the work up front for the discriminant, you get to go ahead and plug it in for over here. Sound good? Then we just simplify, and we get x equals negative 3 plus or minus. This is going to be 3 rad 5, yeah? 3 rad 5 all over 2, and those are my 2 solutions.